So net displacement would mean if we had some sort of displacement going forward and displacement going backwards, we'd add them together, the negative and the positive area. That would be the net displacement. Could be zero, right? If you went forward 20 meters, you went backwards 20 meters, your net displacement would be zero. But if that's velocity, displacement is the integral of velocity. So we just need to find the integral from 2 to 3 of this function. So this is 3t to the negative second. I haven't done any calculus yet, just rewrote it algebraically. If I want to find an antiderivative, then the power needs to go up by 1. And then I need to make sure when I take a derivative, the negative 1 comes down, and then it gets reduced to negative 2. So we're going to be multiplying by a negative 1. So this is our antiderivative. Because if you take a derivative of this term, it turns into this term. So the antiderivative here is negative 3t to the negative first. The antiderivative of minus 5 is minus 5t. And we evaluate this antiderivative with respect to our limits of integration, 2 to 3. So if you plug in the upper limit of integration, this is t to the negative first, so that's negative 3 over t is another way of saying that. And then we need to subtract in parentheses what happens when we plug in 2. So that's negative 1 minus 15 minus whatever this is going to be. That's 10. That's negative 11 and a half. So minus negative means we're actually adding there. So we got negative 16 plus 11 and 1 half. So that's negative 4 and 1 half, which got me negative 9 halves.